Okay, this first program is its only purpose really is to establish, is to show you how to draw a closed object of some kind. This object isn't closed; it's like a room sort of. It's got 5 sides to it. It doesn't have the back side, so you can walk into it and back out of it. But that's a black. That black is a back wall there. So you actually do have an object here that you can go into and out of. I believe I have controls on it. Yes, I do. What's happening now is I've changed the controls from something different than they used to be. What they were originally was the controls was the camera that was going around and would watch the world. Okay, that was the original thing. Now what I have is I've attached you to the camera, and you can stop moving around. You can look around and go here and go there and travel in the world. So in other words, you are the camera, and you're also in games they call it first person. You are the camera and the control and everything. So in other words, you see where you're at just as if you were a person visiting. And I'm going to show you how to do that. It isn't very hard to do, but basically I can go forward. I'm using the arrows to do everything. I can spin around. I can turn around. Notice I turned out through because the box is so small. When I turn around, what I'm doing is I'm turning in a circle around the center point. Because what I did was in this first program, I have the center point is still where it is, and I'm locked to it. I'm actually stuck to it. So in other words, what I've done is I've taken the camera, the 3D world camera, and I've simply allowed us to move it in and move it out and go around, which gives you the impression that it's you. But the trouble is it's still locked to the rules that the center of the world is still the center of the world, and the camera is still looking at the center of the world, and you're still stuck there, sort of. You're kind of stuck doing that. So when you come into here, instead of spinning yourself, you spin around the center of the world, because I'm still using that as a way of turning. I wasn't saying turn the camera around this orbit. What we want to do is we want to get down so that we are the center of the world, and we can look anywhere we want, and we can move anywhere we want, and look anywhere we want, without having to be stuck moving in an orbit. We can actually spin ourselves. And that's what I'm going to do next. Anyway, that's what this one does, and it allows you to, you can do, it looks like you can do almost anything. You can turn left and you can do all these things. But in fact, notice where I'm looking. I'm always looking at that center point right there, at this point right here. It's always the same, no matter what I do. If I turn, if I go backwards, if I go forward, no matter what I do, I'm always looking at the same spot. And that's what this thing is, the camera. We are the camera, and that's the problem. Okay, so let me do the second program. I'll show you how these all work in a second. Let's do the second program here. This one's, it's got the same problem. I'm going to show you. It has the exact same problem as this one has, I think. You go in, see I'm looking at the center of the world, which I moved to the center of this post. The center of the world is now the center of this post. And when I go around it, I'm always looking at the post. That's all I can do. I can't look in any other direction. I'm stuck looking at the center of the world. Because I'm still the camera, and I'm still the camera looking at that world, okay? And I'm telling you that because the program actually shows you that you're the camera looking at this world. Let's go to the third one, though, which is different. Now this one, what I did in this one is I added texture to the walls. The walls didn't have any pictures, they were just colored, that's all. Now they have texture on them, that's what this next program is going to do. And you can spin this one, and you can, now, this is something I want to tell you about. The camera is still in control, the camera is still moving around, okay? So what happens is, the camera, now watch, when I take this camera and I move, I can move behind this thing, and it's black, it's dark. And the reason why is because when I'm looking at the checkers, the light's coming down like this and lighting up the checkers. And when I move around like this, the light is still moving up those checkers, but there's no light on this side, so I'm seeing the dark side. So as the camera, that's the problem. You lose all the lighting and everything. Everything gets pretty screwed up. So, the question is, how do you deal with that? That's what I'm going to do in the next one here. This one here is pretty ornate. Wait a minute, I'm in the wrong place here, I'm sorry. Wrong place here. Let's get it down. Let's get to where we are today. Okay. This is the texture. This is the one where I built a little house. Oh, first is the one before. Let me do the first one first. This is the first one of the first person, where you actually are the person. You are no longer the camera. You are the camera, but you're the camera under complete control of the person driving. So, for example, I can drive straight through this thing, or I can take a left turn, and I can drive this way. Notice I'm not looking at the house anymore. I'm looking anywhere I want to look. I turn around, look anywhere I want to look, and I can go to the house and go straight into it, or I can go to any part of the house. So in other words, and I go backwards too. So in other words, what I have here is 4 arrows and 4 things I can do. I can change directions, or I can go forward and backwards. Okay, makes sense? So this is different than the original camera one. The original camera one, you were stuck in orbit. Now this one will go through it'll go anywhere. You go anywhere you go, it's going to go with you. You have the camera, and you have control over where you're going. I'll show you how that's done. And then what I did was I embellished the house quite a bit. There's a few more in between here, but I get to this point right here where the house was embellished with a bunch of texture. This is just the same old house, except that you go into it and you can look around and stuff, and you can back through the wall. You can do anything you want. It doesn't matter where you go, left, right, up, or down. It doesn't matter what you do. You are still in total control of where you are. You can see where you are. I put a little sign on it too, just to show you how to put a sign on things. If you wanted to, for any reason, if you wanted to put words in these things, it's very simple. You simply put the word on text, and then you show the text. That's all you do is put the text on something. It's just like texture map. That's all it is. And then you can actually see the world. Notice that it has, if you look at this thing here, it has all kinds of stuff. It has the roof. It's got boards inside, and when you go outside the roof, let's see if I can see it over here. When you go outside the roof and look at it, it's got shingles on it. So in other words, it has all the different sides with different things, color images on it, depending what you want. Okay, and also I built this big platform floor here just to have a place to walk on. The last one in this series is quite different. What it does is it takes all the same stuff, except I add one little thing. I add a cylinder to it. I add a cylinder and a sphere. I draw a cylinder and a sphere. I'm going to show you how to do those too. But basically what it does is it looks like this. Hopefully it looks like this. It takes a while to get the textures in, so when you first run, it's getting the pictures in, okay? Now this one here, you're also inside of a, you can look up at things too. You can look up at that if you want to look at it. Getting closer here. You can look up at this thing. Ooh, up above there. And that's the ceiling. All these pictures are just simply taken out. What you do, if you want some pictures, easiest thing in the world. Write down the word that you're interested in Google. It'll come up with a bunch of stuff, hit images, and the images will come up, and you can copy those images, and they'll give you zillions of them. I said Egyptian, whatever, walls, or ceilings, or whatever, and that's what it came up. It gives me whatever I want. So anyway, this thing allows you to go forward and backwards, but it will not let you get out of it. You can't get out of this room. If I back out and try to get out, it doesn't go. It won't go. It also says something, by the way, with the speakers. He turned them off, I think. The last guy that was running to sing. Oh, maybe mine's off. I don't want that. Make it some noise for us. Yeah, it should have said it. Let me try it again one more time here. You can hear it? Okay. So if I try to get out of here, you hear it? It says you'll never escape or something. But basically, it's just whispering. And no matter how you try to get out, you cannot go through these walls. They keep you from going through them. And that's part of the thing I want to talk about today, because if you were to create your own website and you wanted to have some kind of a presentation, you wanted to do stuff in it, you certainly wouldn't want people to go behind the scenes and see how parts hang together and all that kind of stuff. You want to keep them in the theater, in the place where you're looking. So basically, I made this little thing to show you that you can lock people in so that they can't get out. It's a very easy thing to do. Normally what happens is when you have two objects on the screen and you're going to go through it, like for example, if I were going to go through this wall, normally what would happen was it would go right through the wall. It wouldn't stop. Then they have this thing called collision detection. And there's many ways of doing this, but basically what you do is you take the structure of the wall and the structure of the person moving around, or the location of the person moving around. And when that location goes beyond that wall, you say, don't go there. You simply force them to go back to where they were. So in other words, all it simply does is say, is this point too much to the left or the right or whatever wall you're going through? And if it is, just don't go there. Just give them the old point back again. Sometimes you never allow it to go through that wall. And that's really the way collision detection works. In a complicated shape, it's much harder to do, but that's the idea of it. That's how it goes. These images are out of focus because I use cheapo I didn't want to spend a half hour loading the images, so I made them, all your images had to be multiples of 2. Like for example, these images right here, that wall right there is twice as long as it is tall. Okay, so no matter what, I have to have a picture that's twice as long as it is tall as a multiple of 2. So it's 1024 by 512 is what I made it. Okay, I could have made it 512 by 256 or 256 by 128. Any of those combinations will work as long as it's a multiple of 2, like 2 times 2 times 2 times 2 times 2, like that. 128 is a bunch of 2's multiplied. 256 is a bunch of 2's. 512, 1024, 2048, they're all 2's multiplied together over and over and over again. And those, if you have something that's 2 to 1, then this has to be like the long side, like 512, and this has to be 256. So you have to have it in that ratio if this is going to be long side. I made this thing 80 long and 40 high. 80 long, 40 high of those units, whatever those units are. Did the same thing with these guys here. If your picture isn't that size, what you do is you go to X in view, you go up to resize, and you tell the picture to be that size, 128 by 256. It'll do a little bit of this. It'll change shapes, but it doesn't change shapes so much if it's almost 2 to 1 anyway. It changes it so little you don't even notice it. And then save it like that. So what happens then is you have a picture that's now the correct size. Maybe I should make a video just for that, but essentially, this guy right here has all of the things that we want to do for today. Next time, I'm going to do something different. But this stuff here has several things I want to talk about. One of the things is I can go up to, let's see, I've got these pillars in here, which are different. Everything in this thing right now is made up of the square, the cube. Everything's a cube. The floor, the walls, everything, except that cylinder. That's the only thing that's different. I made a cylinder instead of that. So in other words, all the commands that make all this other stuff are simply the same command with different sizes, and then you move them to different places so they'll be in the right place. So there's nothing new in any of those things. The only thing that's new is the cylinder. That's the only thing I've added to it. And up here, these balls up here, those 2 spheres, those are spheres. So now you have 3 things. You'll have, at the end of this, you'll have boxes, cylinders, and spheres. Okay. And that's pretty much all we need. There's another thing I want to make, but I'll show you that as we do it on screen here. And that's pretty much it. That's pretty much what I want to show you. So let me go back to the actual first program here, if I can find it here someplace. This one here. And go to the There it is. There's the program, bring it down. Okay, all this program did, when you looked at it, the only thing it did was it made a little house with 1, 2, 3, 4, 5 sides. It had a 5-sided house and puts it on a platform. I don't know if it does it in this one or not. Possibly it does, yeah. Okay, so let me show you how that's done, how these are done first. This is the first easiest thing, so let's do it. Okay, to begin with, let me go to if I can get there, to this part right here. Can you read that from where you are? Want it bigger? Make it a little bit bigger, see what happens. Is that big enough? Can you read it? Okay. Here. Okay, this is the first part. To start with, what I have here at the body here, I gotta go down a little further, sorry. Oh yeah, I'm okay. Okay, so here it is. The body starts here. The first thing I do is I go to startup. That's because I'm using the mouse for stuff. Or I'm not using the mouse. I guess I don't even use it, so I probably don't even need that. Let me just check. I want to be sure. See what I do with these programs? I add things to them, and I keep going back and forth. So sometimes I leave things behind, junk that I don't need. It's got mouse key, but I don't think oh yes I do use it, okay. Yeah, that has to be there. So in other words, if I'm using anything that involves using the keyboard or the mouse, I have to go to Startup. Because what that does is it goes up to the mouse key and it says, okay, I'm going to use the keyboard or the mouse. That's that include file that we have, okay? And that initiates it, gets it going. So when you click a thing, it comes into you. Or if you click the mouse, it comes into you and it gives you what it has. So that thing has to initiate that mouse thing there. So next thing is, I have this thing, graphics. I've corrected graphics over the weekend. The original graphics allowed you to pull in all the graphics control stuff, except for one thing. The one where the camera was looking this way and that way, okay? What I've done is I brought that into it too. So everything now, everything involved with graphics is in that graphics program. You don't need any other includes. All you need is the includes that would be for the mouse, which is different than graphics. So you still need that one, but the mouse. But this one here contains it all now, so you don't have to do anything anymore with anything. So these guys right here are, I'm bringing in objects. And this is how you create objects. And this is the most important part of this, what we're doing today. First of all, you have to say, I have a variable, and this right here is a name you create. You invent that name, whatever it is. So what I'm doing is I have to say script and var because I'm creating this new variable. And I say my equals new. Those things here have to be exactly the same as they are up to here. Those are exactly the same. I'm basically creating a cube. I'm making a cube, okay? And when I make the cube, what I do is I say I want it to be 40 by 40 by 0.1, which basically says 40 this way, and only 0.1 thick. It's very, very thin. So it's a very thin cube, not a cube really. Okay, so that's the shape of the thing. This right here is the color of it. It's red, green, blue, so it's red. It's a red. What it's going to be is a red. You're going to get basically a red square. That's what you're going to get. And then it says semicolon script, and that's it right there. That creates. That's the command that creates a cube, and that's the name you give. Whatever name you put there is the name it's going to be. We're going to use that up above to make it move around and everything. That's the first thing. The second one I created was exactly the same thing, except it was colored green, and it was also a cube, and it's called your. So there's a my and a your. There's two of them. There's my and your, two different cubes in this thing. And then there's a his. Again, it's a cube, same thing. And this one's green also. So those are both green. Then I made another one, I called it hers, and I made a cube, and I made it 44 by 1, and I called that one yellow. That's a yellow one right there. And then I made another one called theirs, again, same thing, only this time it's yellow also. So there it is. These are my, these are the wall things I created. Then down below here, you see I made another one. This is a different thing. Now this is made slightly different. It starts off, it says script, variable, my floor is what I called it. I gave it this name, my floor, and I said new. Now this one's going to have texture on it. It's going to be a textured map. So no, it's going to be not only a surface, but it's just not going to be a color. It's going to have pictures, or whatever pictures you put on it. It's going to be on there. Okay, and it looks like this. You say text cube this time. See up here we said make cube. That makes just a colored cube. This one makes a textured cube. It's going to expect you now to tell it to give it every picture that's on all of the sides of the cube. You have to tell it the names of all those pictures. Okay, so it's going to be 400 by 400 by 0.1, so it's going to be huge. It's the floor, it's the checkered floor of the thing. So that checkered floor right there, it calls on a ping file, which is checks, which is just a picture of checkers, that's all it is. It's a picture with checkers on it. And I put checkers again, checkers again, checkers again, checkers again. These aren't all necessary, but here's the trouble. I'm making this floor as a cube. I'm not making it as a plane, I'm making it as a very thin cube. So therefore every side has a picture, okay? But I can tell you the rules, how the rules work. It's actually pretty easy. The only two, these guys right here are important if you're going to have depth to it. If it's going to be a real cube, then you need all those different colors, okay? All those pictures. But the only two pictures that really show are the last two. This one shows in the, either the front or the back, I'm not sure. One of these two shows the front or the back. In other words, if you have a flat surface, one of these will be in the front and the other one will be in the back. I'll have to figure out which is which. I can't remember which is which right now. But basically, that's the two crucial ones. If you have a flat plane, those are the two crucial ones. You do have to put pictures in these others, because I haven't written the program very intelligently, so basically you have to put some picture in there. I just put the same ones, that's all. And it has to read them in. It doesn't use them or anything, but it has to read them in. It has to know they're there. Because of the way I've written the function, it says, assume there are 6 pictures. That's what the problem is. So basically, what you do is you write this thing. If you want to have something that's very big and has texture on it, you basically write the thing like this. This is the surface. if you want it 400 by 400, whatever. And then you name the picture that you want to put on that surface, okay, all these places here. And the surface will appear, all sides of it will have that picture on it. And you saw that, this is a different program, okay. So that right there is how you get your stuff in. That's just getting the cubes into the thing with all their photographs on them. And in this case, just colors. These are photos. By the way, this line here is all one line slash script. It says script and slash script around each one of these things. Okay, around each one of these things. Now, you can, if you want to do this, but it's only risky because you're typing stuff, or if you want to pull one of these things out. Basically, what you could do is just get script right here, variable blah 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 semicolon, and then you can just write variable blah 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 semicolon. In other words, you can get rid of all these scripts here. All these scripts could be gone except for the very last slash script. That's the only one you really need. So all these are just basically commands in JavaScript. So you could have all these commands. You say script, and then go all these commands, and then slash script, and they would all come in. You wouldn't need all these words script here. The reason why I do it is because I pull out lines, and then I delete them, then I run the program to test it a little bit, then I put them back again. It's so easy to do that when you have the scripts on here. I can tell which is which. Anyway, so that's just that's how it's done. So that's how you set the thing up to get it ready to start drawing stuff. Now, the next question is, these guys right here have names. Each one of these objects that you've created has a name to it, okay? This one right here will have the name my.cube. That's its name, .cube, because you created a cube. So this one's my.cube, this one's your .cube, this one's his .cube, hers .cube, theirs .cube. This one's not the same, because this is created by a text cube rather than a make cube. So what I did is I gave this guy here text cube as the name. So what you would have is your name, my floor, .text cube. These up here will say my.cube, and this one right here would say the name of it, my floor .text cube. Okay, well I'll talk about that a little bit more. But basically the idea is that you name it, but it's also a type of object. And that type of object has to be there, has to be there. So in other words, I said, this is the name of the thing, and this is a text cube. This is the type of object it is. This one up here says my cube is the type of object it is, okay? I would like to have made these words the same as the words I use up above, but it turned out they conflicted for some reason, so I couldn't do it. So basically, that's what we have. That's the, do you understand the strategy? Want to make a colored cube? Use those. Want to make a cube with texture? Use that one. And you can give it any name you want, by the way. Any name you want here, or here. These are all your own names. But the other part has to be the same. Well, it has to have the dimensions and the color. That's all they have to have here. Down here, you have to have the pictures, each of the pictures that you're going to put in that cube, plus its dimensions over here. And that's it. That will create the objects. That says the objects now exist. Now the question is, how do you see the objects? Okay. Here's the basic principle of 3JS, how it works. You get points in space. It takes those points and makes triangles out of them. It takes those triangles and makes a mesh out of it. And then it takes that mesh, puts texture on it. Then it takes that mesh or texture and puts it in the scene so you can see it. Okay? We're about to put it in the scene. Right now you can't see them. They're all there, but we haven't actually shown anybody anything yet. So to do that, what we have to do is we have to go to render, and render is how you do it. Everything's done in render. It draws the things, it moves the things, it does everything. Render is the actual, the verb of the program, really. It's what causes everything to happen. So now that you've got all the stuff in, and you have to put it down here, by the way, you have to put it in the body, right here. Then what you do is you bounce up, right here you say, let's go to render and see what happens. Make something happen. So in the render part, get up there. It's right here, and it's huge. The render part is really huge, okay? Let me start right here because, yeah, I'll start right about there. Okay, first thing I did was, I wanted to make I had function render, which means this, from now on, everything here is going to be drawn on the screen. So I said, request animation frame render. What that does is, I want to animate this thing. I want it to keep, in other words, if I move something, I want it to show me that. If I move something, I want it to show me that. So what happens is, just like the previous times when we were going back into the function to make it do something, back in the function, make it do something more. We're doing the same thing here, only that's the command to do it. That tells you when this thing is completely created and on the screen, it goes back and starts to create the new screen. Okay, so the frames are as fast as it could possibly be. It's rigged to do it perfectly. So right there is the nifty thing. It's sort of like frames in a camera. It just simply makes the next frame. So that has to be there. And it has to say, if this is called render, then that has to be called render. By the way, the name of this thing does not have to be called render. You could call it something else. But every program I've ever seen, everybody calls it render. So we're going to call it render because if you copy anything from any place, you want to take some pieces, you want to take it containing render rather than anything else on it. So render's the line that we need. That's the one we're going to need. And that's where you go back to. It's always, whatever this is, that will be also. Except that one doesn't have any two parentheses around it. That one does. Okay, so now we start off, here's the objects, and here's what we're going to do to the objects. We can make something happen to them. We can draw them in different orientations. All the objects start off at the origin, pointing towards you, and you're in the Z direction. And so what you do is you say, this says that the first cube we made is going to be positioned, its X position at 0, which means it will not be to the left, right, it will not be to the left. It's going to be right in the middle of the origin. This right here says minus 20 for the Y position. Minus 20 means it's going to drop down in the Y direction 20 units, whatever that is. That's not pixels, it's their own units. And then it's going to be in the Z direction 0. So therefore, the only thing that happens to the first one is it looks like this. It drops down 20 and stays there. It doesn't do anything. Then what you do, now that you got it down 20, you go down to see its rotation. What do you do with its rotation? This is where we put it. Now I want to see where we rotate it. It's sitting down here. It always rotates with respect to its midpoint, whatever that is, its own midpoint, because it knows its own X, Y, and Z, and it always just rotates according to itself. So this thing right here says your cube.position.x equals my cube.rotation.x equals math pi divided by 2. Math pi is 180 degrees. It's like 180 degrees. If you divide it by 2, you're up at 90 degrees. So we get 90 degrees here. So what I'm saying is rotate this thing over X 90 degrees. And when I do that, when I rotate this thing, which is now down here, over X at 90 degrees, it rotates. And now what it's done is it's flat with the floor, but yeah, it's flat with the floor. So let me see if I did something, what I did here. Let me see if I like this. Minus 20, flat with the floor, yeah. Okay, so it's flat with the floor down here. Yeah, that's okay. So what it is you now have a floor in the thing, and that gives you the first thing, gives you a floor. So you have something on the bottom there. Let me run this program. I want to be sure I'm not talking with my hat here. Yeah, I'm good. That's red, right? The thing was red originally, yeah, so that's it. So that's the floor. That's how we got that floor right there, that red floor. You see it right there. Okay? Now, then we go on, and I go to the next objects. I have all these objects I made originally. I have a second cube, which I moved it 20 up, and then 90 degrees. Like, where did I put that one? 20 in the X direction. No, I moved it 20 in the X direction over that way, and then I rotated it 90 degrees. Okay, so I went that way, rotated 90 degrees over the Y-axis. Okay, so here's what I did. With this one, I had it on the back. Everything starts on the back wall. I moved it over here, and then turned it 90 degrees over the Y-axis. So now it's a wall over here. Originally, everything was flat in the back there. I had to take, the first thing I took, I brought it down and flipped it this way. And the second thing, I'm bringing it this way and turn it this way. Now I'm going to take one and go this way and turn it that way. And then the two roof ones are a little more complicated, but basically I did the same thing. Let's just look to I'll go to the roof ones right now because the others are all pretty much the same. This one right here is the roof one. Right here. It says 14 and minus 14. Yeah. These are the roof ones right here, between here and here. Now if you look at the roof, it looks weird, doesn't it? It's got two things at this angle. So you have to get the back wall into that angle there. That's the trick, how you do that. And that's something you should get used to. It's just doing it. That's all you really have to do is do it and see how it works. You're going to start off this thing right here and right here. Both start off on the back wall. So I take this one right here and I say move it 14 in the X direction. So I move it this direction 14. And then I move it 26 in the Y direction. So I move it up to here. Okay? Then what I do is I rotate the thing over the X-axis 90 degrees, which puts it like this. And then I rotate it 45 degrees like that. And that's what does it. It gives me that, now I get that side of the roof right there. So in other words, that's what creates the left side there. This one over here is exactly the opposite. You move this one this direction over here, and then you move it Y26, so you move it up to the roof, and then you rotate it 90 degrees to get it this way, and then you rotate it 45 degrees to get it to look like a roof over Y. And that's it. That's how it works. And so now what you've done is you've created these two roofs right here. If I'm not mistaken, I hope I did that right. I think I did. And so that's how you get these two originally back walls. See, both of these yellow things were originally in the back wall. They were right here. I had to move them over this way, I had to move them up, and then I had to tilt them so that they would cross each other at the summit there. And that's it. That's pretty much how it, back up here a little bit. That's pretty much how it works. So in other words, what this program does is it says, make these objects, and then as they come off the back wall, put them in position so that they'll form the structure you want. That's all you have to do, and that's all that program really does. If you look at the variables in it, like above here, let's look at the variables a little bit. First of all, you have to have camera radius and degrees if you're going to use this control down here, which I might have shut off, but I don't know if I did. Yeah, I did shut it off. Okay, I'm sorry about this. Here's some things that are going to happen in some of these programs I'm kind of uncertain about. What I've done is, some of the commands that I say you should have in every single program, some of them I just erased. I dropped them out because I didn't need them anymore. I don't need to control where the camera is when I have no camera anymore. Now it's just me moving around. I've taken over that job. So therefore the camera rolling in the orbit out there isn't necessary. So I just took all the commands associated with that out. What I didn't take out was the actual information. Degrees is how much that camera was rotating, and camera radius was how far is the camera from the center, so it would know how to turn. So if you just kill that camera, you don't need that anymore. What I did down below here, if you look at it, I didn't ask for camera X and camera Y, except right here. I asked for it here, and because the reason why I asked for it this way instead of the other way is because now what I'm doing is I'm carrying the camera on my back and I'm looking around at things. So as I'm no longer locked to radius and angle of turn. I'm not locked to that anymore. Now what I'm locked to is something different. Now I'm locked to where is my X and where is my Y. So if I say from the center origin, if I go here and here, and this is where I am, then if I look at the center of the world, I'm looking at it from some place I just went to. I'm going to draw that on the board afterwards because I think it's too hard to do. Originally it was radius from the center of the world, the camera moved left or right. Now what we're doing is we're going in and we're not looking at the center of the world anymore. We're looking wherever we want. Look any place you want to look. And the camera moves by jumping to another XY. I want to go to this XY, I want to go to that XY. In other words, I want to go to some position. I don't care about the radius anymore, and I don't care about the angle of the thing. I just care about what position I'm going to. And this makes that change. So I want to go through that change on a board, I think, rather than do it here, because it requires a little bit of diagrams and stuff. So essentially, though, this program, I'll look back at these variables again. This program's variables are up here, are degrees and camera radius, and those are the things that I'm not using anymore. And then turn, I am using that because that tells me how much I am first person turning. What's my angle? What am I looking at? That's the variable that keeps track of that. D5 is how far am I moving with each move. So when you hit the forward arrow, it jumps forward. It jumps forward D. You can set that. You can say how you want to jump 5 or 4 or 2, whatever. Every time you hit the arrow, it'll jump D. It'll jump that far forward. And so if you hold the arrow down, it'll go D, 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 like that, keep going forward. So essentially what you can do is, D is always going to tell you how far you're going to move forward, and turn is going to tell you what direction you're moving in. So in this room here, all I have to do is say this. Originally, I was looking at the center of the world right here. And now when the thing turns on, it looks at it. So if I go over here, turn is going to say that angle. And distance is going to be how far I go in that angle. If I turn this way, now turn is this angle, and it's how far distance I go in this way. So every one of these XYs that I hit, every one of these XZs that I hit, by the way, is where I'm at. And then what I do immediately, I say, okay, now that I'm here, look around. So I can hit turn again. I can look anywhere I want. I can look at the objects. I can look off the edge. I can look anywhere I want. But the minute I take a step, it takes the calculation of that angle and that D, that distance, and it goes, I go this far here, and it recalculates my new XY, okay? It's all automatic. You don't even have to think about it. All you have to do is be sure you grab the functions that do that for you. In other words, you say, I want to go this much in this direction, where am I? And when you do it, it'll give you the where am I, then you say, put my object in that position, because that's where I am. I am me. I am an object, and I'm in this position. So you put the camera in that position. So essentially, you become the walking camera. They call it first person, and I think that's something you have to do to actually go through labyrinths and stuff. You have to actually do that. This is not the best way to do it, I have to tell you. It's better to do it with the mouse, but the mouse command's a little bit harder, so I said, let's not do that. It gets complicated, right? We can do that later for this particular time. So in other words, what you have in this thing at the end is you can actually navigate the entire surface and look anywhere you want. That's the procedure in this program here. Let's go to the next one here. Take a look at it. Actually, I'll go to the let's go to the second to last one. Standard shapes. I'm going to do this one right here. This is a jump away from what we've been doing, but we'll go to it. This is that right here. Okay, I'll bring it down. Here, like so. These are actually all the objects we'll be able to use right now. The objects we have available, the standardized objects, is you have a sphere, you have a block that has just color to it, you have a block that you can color all the different sides differently, you have a block that you can put texture on, you have this, I call it a donut, but it will actually allow you to put texture on it also. You can make you can put anything you want a picture on it. This one has a picture on it. And you have a cylinder right here. The cylinder is kind of interesting because not only can you have a cylinder, but you can take that cylinder and you can reduce the size of one of its ends so it becomes a cone. So you can make a cone out of it if you want to. I'll show you all that. And so these are the objects we have available that are built in, that we're going to be able to use built in. If you want to have something different, like a head or a dog or anything else, it's possible to do that. And what I'll show you is, I'm going to show you how to bring in an object. You take an object and bring it in, any shape. It's already designed someplace else in Blender, particularly in Blender. That's the program that normally people use. It's free. It's three-dimensional graphics. You just make this object with its structure, and then you say, import this to my program. You just write the name of it in your program, and then this program will pick it up and it'll put the texture where you want to put it. It does exactly what you tell it to do. So essentially what you can do is you can bring stuff into your program that is any shape no matter what it is. Easy to do as long as you have the shape. There are places online where you can actually get shapes free. You just say, give me the shape of that shape, and it'll send it into you, and you have it, color and everything. And you can just put it in your program. Like that Earth, for example, right there. That came from somebody. They made a spherical Earth, and then they made this map that makes the Earth, which is just a texture map, that's all. And by the way, I want to mention this now, this is something important. If you're doing a sphere, if you're putting texture on a sphere, sphere's a weird shape, what you have to do is the texture has to be twice as wide as it is tall. Then it will wrap pretty good. It'll wrap pretty well. It'll lay on there pretty good. If you don't do that, if you don't do it that way, what will happen is your texture will get kind of twisted. It won't look good, and it won't like the Earth looks like the Earth now. If I had made it different dimensions, you'd see the Earth sort of, and then you'd see a line where it cut because they aren't lapping quite right. And so what you get then is a seam that you don't want. But if you make it exactly like 1024 by 512, then you'll get exactly, it'll wrap on there perfectly, and it'll fit perfectly, it won't come over the edge. And so that's what you should know about that texture map. But I'm going to do those right now. I can do those while we're in this program here. let's go to, see what it looks like. What I'm gonna do is show you the commands that draw all these different things, okay? It's right here. It starts off the same way as the other one. You have to bring in a bunch of objects. Okay. You have to bring a bunch of objects in. It's right down here at the bottom. This is them. They're all being brought in. I'll start, right? Let's see. Get some space off here if I can. Okay, here's the beginning of the HTML. It's got onload and render, just like before, okay? We're not using any buttons in this one. We're not using any buttons, so therefore it doesn't call for the other part, for the keystrokes. So here we have render, and we have graphics. And now, this thing right here, that I'm marking on right here, that makes a cube, and I call it my, just like the previous program. This one down here makes a colored cube, which is different. Each one of these, it says it's 2 by 2 by 2. It's called color cube. That's what you write, color cube. Then you name the color. You just put down colors in here. You don't need any quotes around them. Just put down the color names, okay, of the 6 sides of your sphere, of your cube. This one down here is the one we did in the previous program, I think. It creates a textured cube. It's 2 by 2 by 2, and now it has a picture for side 1, a picture for side 2. It's like a dice. So you have all the different sides, and I have a picture for every side in that one right there. Then I go down to this one here. I make the sphere. This is the sphere with the earth on it. So to make a sphere, what you do is you say, call it anything you want. That's your name, and say new sphere, and then you give it. This right here is the radius. These two, 32 and 32, are how many lines are there this way and this way? In other words, how many lines do you have? If you make too many, like if I made 4 and 4, the earth would look like a bunch of flat surfaces. If you make 32 by 32, it gets pretty round. If you make 64 by 64, it's very round. The trouble is, the more numbers you use there, it looks nicer, but it takes a lot longer to bring in. It's much harder for it to calculate. So basically, 32 is about right. That's within the framework of our machines. I have a very old machine, so I like to keep it at that. So that's how you create a sphere, and this right here is the texture you put on the sphere. That's the 2 to 1, whatever you put, whatever color, whatever you put on there. This one right here, I called it nut, and it's a torus. It's the donut, okay? And it's 2.41 is, let's see, the torus has 2 radiuses. The first radius is the torus's donut itself. The second radius is the radius of the torus, the donut. In other words, one's the radius of the whole donut, one's just the radius of that part right there. You can see that the 2.41 is the radius of the entire donut. From here to here is the radius. And then the 0.2 is just the radius of the thickness of the donut, really is what it is. That's the radius of that. And then 50 and 50 are the same thing. It's how many lines do you want to make it precise. If I put 10 by 10, you'd see little flat surfaces. And with 20 by 20, they'd be a little bit smoother. 50 by 50 is pretty smooth. In other words, the more numbers you put, the bigger the numbers where you have 50-50, the smoother it is, but the slower it takes to draw the thing. So therefore, that's how you do it with that. And then finally, the cylinder, which is the critical one we'll be using a lot of. The cylinder right here is 1.5, 1.5. Again, the cylinder has 1.5 radius at the top and 1.5 radius at the bottom. That's what I said here. If I made one of those 0, it would become a cone. If one of those 1.5s was a 0, it would be a cone. It would be this radius over that radius, 0 over 1.5. So therefore, it would form a cone. And that's how you make cones, by the way, just doing it that way. But this one here is 1.5 by 1.5, which means it's 1.5 at the base and 1.5 at the height. And again, it has 32 by 32. It has 32 lines this way holding it together, and 32 circles this way holding it together. And that gives you a pretty good surface. It isn't too bad. And finally, I put this texture on it right here. Text3.ping. That's just the picture I put on it. Like in the case of marble, the marble, whatever they are. What's the word I'm looking for, you guys? Columns. The columns I put in the Egyptian thing. Those columns are just simply cylinders, and they have a marble texture on them. I went on the web, says, show me some marble, show me some marble. I took a piece of it. I made it 512 by 512 or something like that, so it had the right numbers to it in X and U. Then I saved it. Then I used that texture right there. I just put it in there, and that was it. It made the perfect cylinders. I made all kinds of things like rockets and all kinds of stuff with these cylinders. They're pretty good, because between the fact that you can make a cylinder this way, you can make one a little bit this way by making the upper radius smaller than the other. You put them together, then you make a tiny one, probably a point. You can make a sort of a sort of a rocket surface on the front end. So because of the pyramid, the cones you can make. And that's it. That's how you make this thing. When you look at it, all I've done is got them all listed off here. And that's all we have. That's pretty much it. There we go. So now you could actually draw these things. And don't forget, it's easy to do. Just experiment a little bit. You'll see how they work. But there are 5 things here. There are a sphere, a cube without color in just one color on it. This is a cube where you can put the color on each face. This one over here, oops, if I get it over here. This one over here is a cube with a different picture on each face. And this one over here is a donut with a picture on it. So just take a picture and plug it on there, and it lights up for you. Okay, and that's it. That's that part. So let's go back to the Egyptian one, which I think is the one we should talk about a little bit. Yeah, right. Okay, there's a lot to this one, but the essential thing is that every one of these things is a textured map cube. That is up there. These beams are everything there except for the cylinders. That's the way, everything is just a cube. So there's just a bunch of cubes with different lengths, widths, and heights. And all I simply had to do is, they were all created originally here. And what I had to do when I drew the things, I had to move this to here, and that to there, this to here, that to there. And you basically even have one that's behind you. It's out here that I put up behind you, which is easy to do. You just tell it where to go, and it goes there. And if you set your original radius to where you are as being inside this thing, you can't get out of it. Because what happens is this. When you go to move someplace, it says move D in this direction. So in other words, when you press the button, it goes D in that direction. Suppose it goes this way and hits that wall right there. Well, what happens is that wall is at, I think it's at -40. That's its -40 in the X direction. So what I simply do is I make a move. I say move, and when it goes to -40, it says, oh, we're going to be bigger than -40, less than -40. So don't make that move. So it brings me back to here. It doesn't allow me to make that move. And the same thing with this wall here. This one here may be in the Z direction, maybe -20 or 40 or something. So if I go too far this way, it will say, where am I now? It'll say, well, I'm less than -40 in the Z direction. Can't go there, bring me back. So in other words, what I do is every single time I try to go in some direction that goes outside of these borders, this is +40 here. I can't go bigger than +40 in the X direction. Can't go less than 40 in the Z direction. Can't go greater than 40 in the Z direction positive. I can't go out here. And I allow myself to go this way at less than 40. So in other words, if I hit any of those numbers, and all I have to do is ask the question, as I move along, I immediately ask the question, is my X or my Y, is my X or my Z outside of the range? If it is, bring me back in and say I can't go there. That's all there is to it. It's a simple collision detection. So let me look at the code just to show you how that works. Okay? Because as you see, I can run as fast as I can, try to get through this wall, but when I hit it, bam, I cannot go any further than it. Won't allow that. So let's look at the collision detection routine here. If I can find it. If I can find it. That's wrong. I know I can't find it, it's the wrong program. Okay, here's what happens. Up here at key hit, I'm obviously to move someplace I have to hit the arrow keys, right? So if I hit the arrow key 38, or 39 and 37 are the ones that tell me turn this way or turn that way. Those are the two right and left arrows. All I simply do is if I hit a left arrow, I make myself turn this way. If I hit a right arrow, I make myself turn that way, 4 degrees. Okay, that's all I do. If I hit 38 and 40, now what I'm doing is I'm either going forward. If I hit 38, I'm going this way. If I hit 40, I'm going this way. So I'm going forward and backwards. That's different. Looking different ways is no problem. It's when you start to move, you might go through the wall. So what I say is, okay, instead of going through the wall, what happens is I say, okay, I'm either going this way or I'm going reverse. This is the forward direction, and this is the reverse direction. So if I hit 38, I go here. If I hit 40, I go here. Now, if you look at these two functions, there's the forward direction function, and there's the reverse direction. What I do is I calculate, based on D and the turn I have, how far I will walk and how much angle I'm pointed at, I calculate my new X and my new Z positions. This function right is brand new to you, but it's exactly the same one I used with the cameras before, with the camera. The camera has one that tells you where the new camera position is. This one tells you where the new U are, where you're located. So you're located at total X and total Z. That's where, X and Z, that's where you're located. That's what you just changed. That's the amount you just changed. Because it's a right triangle, I move a certain amount this way and a certain amount in the Z direction. So therefore, that's how much I'm going to move. Then what I do is I add that number to the total move I've already made. So it's where am I now, plus the change I just made tells me where I really am. So if I'm at 30-30 and I go 1-1, I'm going to be at 31-31. Okay, so you have to, that's what you do. You add where you are to the change in D. Where am I now? So what happens is when I look at X and total X right here, which is my new X position, I say if it's greater than or equal to 38, which means I'm almost hitting the right wall. Then, or if I'm less than 38, hitting the left wall, or my Z is hitting positive 38, which is my front wall, or negative 38, which is my back wall. If any of those are true, I play this sound that says, you can't get out of here, and I return. I don't allow myself to do the new calculation. I don't let myself move. This is where you move. You take total X, add that new X to it, and that's where you are now. Take total Z, add the new Z to it, and that's where you are now. But I don't let that happen. These two guys keep track of where I am right now, where the camera is. But before I find out how far I would go in X and Z, and then I theoretically say, well, if I theoretically were at X plus total X, would I be greater than 38, less than 38, or in the Z direction? If any of those are true right there, I play a sound that says you can't get out, and I return, which means don't finish this function. Get out of here before you do that calculation. And that's how you avoid going through the wall. You simply don't allow yourself to. You look to see, will I go through the wall? Let's get out of here. Don't make that change. Because once you say total X plus X equals total X, you are now through the wall. That total X and total Z tell you where you are at every single time. And that's up above you. It's one of the variables you have, total X and total Z. Originally, total X was a 0 and total Z was 35. Because I wanted to be back from the thing so I could look at it. So I moved myself 35 back to look at the scene. But it's still inside the 40s. I'm still inside the 40s on all sides. I don't get out. So basically, I create the guy inside the Egyptian thing, and I never let him out again. Okay. The rolling spears. Let me see if I can. Those are kind of peculiar. Cube. I'd like to put off a discussion of the rolling spears because I'm going to change it. Next class, I'm going to show you something that's really interesting and very helpful. If you have a car going down the street that's got wheels on it, okay, and if the wheel is an object, and this wheel is an object, and the car is an object, and if you say to your program, okay, make my car go 5 miles or 5 to the left, okay, so it goes 5 to your left, it would go that way, it would go over there. But the wheels would still be stuck here, they wouldn't leave. I'd have to take every wheel and move it like that. So, the next question is, if I glue them together somehow, and I say, turn the wheel, then the whole car will flip with it, because they're all glued into one object. You can't do that either. So what you have to do is you have to create what they call a hierarchy. It's a very weird idea, but basically, the car can move anywhere it wants, and the wheels will go with it. But if you turn the wheels, only they turn. In other words, you can tell the wheel to turn, or you can tell the car to move. If you tell the car to move, the wheels go with it. If you tell the wheels to do something, the car doesn't go with it. So the wheels just turn, it doesn't do anything, unless you tell it to. So basically, it's like this thing I told you, the shoulder, the elbow, and the wrist. If my hand moves like this, it's because it's hooked onto this, and that's because it's hooked onto this. If I move my shoulder, everything moves. If I move my elbow, my wrist moves. If I move my wrist, nothing else moves except my wrist. That's called hierarchy, and that's the thing that will allow us to make a planet, make a moon go around it, and make a moon go around that moon. And they'll all be independent, so that the little moon can do what it wants. When the big one does, when the second biggest one does something, the little moon sticks with it, it doesn't move away. And when the whole planet does something, everything moves. So in other words, it's a hierarchical thing. Planet control, let's make it the sun. The sun controls the planet controls the moon. But not vice versa. When the moon does something, the sun doesn't do anything. And so I'm going to show you how to do that. So that hierarchical thing will give you the ability to do all kinds of stuff that you can't do otherwise. And it's very, very simple. But it gives you, you create an object, you say this object is under this object, sort of part of the hierarchy, and this one's under that one. So if you move this one, nothing happens except this one. If you move this one, then both of them move. When you move this one, all three of them move. And that gives you enormous power when you're trying to create a world in an artificial universe like this. And so that's pretty much it. What do we got? We're going to get 3 o'clock, but I think you got a lot there to look at. Don't forget, all these things, that it looks like a big program, it looks enormous, but it's just the same thing over and over. Make this block, make that block, make this block, make that block. Which way does this block point? Which way does this block point? Which way does it's just repetition over and over, which is not uncommon for programs. They have lots of duplication. So even though this looks big, it's still pretty much a very, very direct, straightforward program. If you can do this, my thought is that you could actually create web pages that are far more interesting than, as far as the person could look around and you get sound. We're going to add video to it and webcam. We can add everything to it. Everything we have can be added in here. We can use it. And so that'll give you the ability to create quite an interesting atmosphere. And when we look at Blender, you'll see that it's not that hard to work with. It's a big program. It's free. And you can see that you can make stuff. You can make all kinds of objects and you can put them in your world. Or you get somebody who's good at it to do it for you, put them in your world. And then you can create a much more interesting web page than you can now. That's pretty much it. If you got any questions, I'll be here for a while.